In May 1976, about 50 light years away in the constellation Centaurus, astronomers discovered a white dwarf star. Later, it was nicknamed Lucy, after the Beatles' song Lucy in the Sky with Diamonds. Years later, scientists realized something incredible. 90% of Lucy's mass has crystallized into carbon and oxygen, making her essentially a giant cosmic diamond. But how did they figure that out? To understand that, we need to understand three things. What is a white dwarf made of? What tool did they use to come to the conclusion? How did they read the data collected by the tool? 1. What is a white dwarf? When a sun-like star runs out of fuel, it sheds its outer layers and leaves behind a dense, hot core. That core, called a white dwarf, is mostly made of carbon and oxygen atoms. Inside a white dwarf, the pressure is millions of times greater than Earth's atmosphere. That's so intense that it forces carbon atoms into a rigid crystal lattice. This is the same atomic structure that forms diamonds here on Earth. Put simply, white dwarfs have just the right pressure and material to make diamonds. On Earth, diamonds form in small chunks, but in a white dwarf, it's a diamond the size of a star. Again, Lucy is a white dwarf, so she has the perfect conditions to turn into a cosmic diamond. 2. What tool did they use? Now, you can't exactly fly 50 light years and take a sample from the star. Instead, astronomers turned to the Whole Earth Telescope, WET. The WET isn't one telescope, but a global network of observatories. As night ends in one part of the world, another telescope on the far side picks up the observation. It's like a relay race around the planet, ensuring astronomers can monitor Lucy 24 hours a day without interruption. This non-stop watch allowed astronomers to gather the vital data needed to determine what Lucy is made of. 3. How did they read the data? This non-stop watch was critical because Lucy doesn't shine steadily, she flickers ever so slightly. These flickers come from pulsations or vibrations deep inside the star, much like a bell ringing after being struck. But why do these pulsations happen? As a white dwarf cools, its outer layers trap heat. That trapped energy builds up pressure, which occasionally pushes outward and then falls back in. This rise and fall makes the whole star expand and contract slightly. These tiny movements create regular beats of light that astronomers can measure. Here's the clever part. Different cores create different vibrations. A star with a liquid-like core produces one set of pulsation patterns. A star with a solid, crystallized core produces another. Astronomers already had models that predicted exactly what each vibration song should sound like. So when they used the Whole Earth Telescope to capture Lucy's pulsations, all they had to do was compare them. And when they observed Lucy for years and compared the result with the existing models, the result was clear. Lucy's vibrations matched the pattern of a star whose core had crystallized into diamond. This meant that about 90% of Lucy's mass had crystallized into solid carbon and oxygen. In other words, Lucy is the largest diamond ever known, weighing an unimaginable 10 billion trillion carats. So, in short, it was Lucy's pulsations that revealed what she's actually made of. Among astronomers, this wasn't just a flashy discovery. It confirmed a major theory of star evolution. As white dwarfs cool, their carbon interiors freeze into crystals. And it reminded us that the universe doesn't just contain stars and planets, but also treasures beyond imagination. Lucy truly lives up to her name. Lucy in the Sky with Diamonds.